Welcome to another review session with your Pokemon professor. Joining us today we have Gengar to help us learn about simplifying expressions. In order for us to understand how to simplify expressions, we need to know the order of operations. Some of you may look at this acronym that I use called GEMMA and think, wait a minute, that's not the acronym I learned. Right, you may have learned something called PEMDAS. I'm not a fan of PEMDAS. I think it has too many problems with it. So instead, I use the acronym GEMMA, which helps clear up some of those issues. So when we start out here, we start with the letter G. The letter G stands for grouping symbols. In math, you have a number of grouping symbols, from parentheses to brackets to braces to root symbols to division bars, as well as a few others you'll learn about as you get into higher level mathematics. All of those can be encompassed within the phrase grouping symbols, unlike the normal P of PEMDAS, which only handles one of those. The E is still the same. Exponents. When we get to level 3, I've now simplified it down to just a single M to stand for multiplication. Now some of you may be thinking, well, wait a minute, what about division? Well, here's the thing. Division is actually just a shortcut. It is a shortcut for multiplication. So instead of leaving it as its own separate step or causing any type of confusion here, understand division is just another way of thinking about multiplication. Therefore, we don't really need it. We just need multiplication. The last step is addition. And again, you may be saying, well, what about subtraction? Subtraction is just a simplified way of thinking about addition. So again, subtraction is just addition, so we don't really need it. We can just go with addition. So the order of operations are grouping symbols, then exponents, then multiplication, then addition. Now let's take a look at some examples over here for simplifying numeric expressions. Notice these expressions have only numbers, so they are numeric expressions. As we look at this, some of you may be wondering what's going on with this dot right here. This dot stands for multiplication. Up until now, you may have been using an X to represent multiplication, but as we move into algebra, the X will get used inside of our algebraic expressions and our equations, and so using X for both multiplication and as a variable can get quite confusing. So instead, we eliminate the X as multiplication and we use a dot instead. Okay, with that cleared up, let's do our order of operations. As I look through here, I see no grouping symbols, so I can now move down to step 2. I look through here, I see no exponents, so I can now move down to step 3. As I look through here, do I see any multiplication/division? And I sure do, right here and right here. If I have 2 of the same operation, I need to do those operations in order from left to right. So as I look at this, the first operation, reading it from left to right, is 12 times 18. So the first thing I need to do is take 12 times 18, change that into a single number. So the 11 comes down, the addition comes down, and I get 216. The division comes down, and the 9 comes down. Now, I need to handle the division. The 11 comes down, plus, and now 216 divided by 9 is 24. And since I've run out of room, I'm going to use a right arrow to say that 11 plus 24 is 35. And there we go. Okay, we got 3 more examples. At this point, I encourage you to pause the video, look at these 3 examples, try it yourself, see what answers you get, then start the video again so you can check your answers with mine. Okay, welcome back. Hopefully you've gotten your 3 answers and now you're ready to see if your work compares to mine. As we go through here, with problem number 2, I see no grouping symbols, I see no exponents, I do see a division, which is at the 3rd level for multiplication. So I'm gonna take care of that first. And I get 13 minus 14 divided by 7 is 2 plus 17. Now, I see both subtraction and addition, which are both on the 4th level. So in this case, I need to do them in order from left to right. So from left to right, I need to do the subtraction first. 13 minus 2 is 11 plus 17, and I'll use an arrow again for a final answer of 28. Okay, moving on to problem 3. Here I do see grouping symbols. I had parentheses, so they have to go first. And 15 minus 5 is 10. Oops. And now with my new expression, I see division. Or I don't see any exponents, so I can skip that step, and now I'm down to multiplication / division. I see a division, so I have to do this step next. Bring down the 10, bring down the addition, and now 15 divided by 5 is 3, and 10 plus 3 makes 13. Okay, last one. In this case, as we look at this example, understand that this is a division bar. And a division bar is an example of a grouping symbol. So we need to simplify the numerator, which is one group, and the denominator, which is the other group. And we have to simplify those groups first before we do the division. So when I look at the numerator, all I see is an operation of addition. So I am going to do this operation, 14 plus 26, and that gives me 40. And now I combine the denominator as a separate second group. 4 plus 4 makes 8. And now what I have is a fraction or a division problem. 40 divided by 8, which of course is 5. Okay, so hopefully your answers are the same as mine. Give me 2 seconds to do a little magic, and we will move on to our next example. Okay, welcome back to our second part of this with algebraic expressions. Now, to understand how to simplify algebraic expressions, they do follow grouping symbols and exponents in the same order, just like our normal operations, order of operations. When we get to this next level, level 3 of multiplication, there is a property that we use that represents multiplication regarding algebraic expressions. That property is known as the distributive property. It's where if you have a number or variable multiplied to an expression, you can take that number or variable and multiply it to each of the items inside those parentheses. So here with question 1, we have a 2 being multiplied to the expression 3m plus 9. So in order to do this multiplication and simplify this expression, we need to multiply the 2 to both items or both parts of the expression. So I take 2 times 3m. Imagine if you had 3 markers and you doubled those amount of markers, you would end up with a total of 6 markers. Or another way of looking at this is I took the 2 numbers, multiplied them together in order to get the total number of that variable. Then I take 2 times the positive 9, Because here, even though this is addition, I'm also going to think about this as a positive 9. So you may be thinking, well, when do you think about it as addition? When do you think about it as positive? Depends on the situation. When it's the right time to think about each. And you'll learn that as you go through mathematics through middle school and high school. So 2 times positive 9 makes a positive 18. So I'm going to bring this down as plus 18. Now, why do I bring up this positive? Well, because sometimes we can multiply with negative numbers. So when we have a negative 4 multiplied to this expression, the negative 4 is multiplied to both parts of the expression. Negative 4 times 9. Negative 4 times 9 makes a negative 36. Now, I want to think about this second part of the expression, minus 6w, as negative 6w. So I'm taking negative 4 times negative 6w. Negative 4 times negative 6 makes a positive, because a negative times a negative makes a positive, 24w. So if you have algebraic expressions that contain multiplication, it's going to show up like the distributive property, and you need to use this property in order to handle this level of multiplication. Now, you may be going, well, isn't there one more level? Yes. The last level is addition. When we're dealing with algebraic expressions, this fourth level of the order of operations, we typically call it combining like terms. Now, when it comes to like terms, you have to be able to identify from your expression which terms are the same. We have terms that are just numbers, and we have terms that contain the same variable. So terms that have just numbers would be considered like terms. So what I can do is I can actually use parentheses to group them together in order to combine. Now notice I did 4 minus 3. That's because this number here is minus 3, and the minus needs to stay with the 3. So it becomes 4 minus 3. Then I'm going to put a plus between here, and I'm going to combine or group together the variable terms, 2m, and again, the minus travels with the 9m. And this is me grouping like terms, so now it's time for me to combine those like terms. 4 minus 3 becomes 1. 2m minus 9m becomes negative 7m. So instead of writing plus negative 7m, I'm just going to write it as minus 7m to still represent that negative 7m. So simplifying expressions, whether numeric or algebraic, are pretty much identical, but sometimes when it comes to multiplication, you're going to have to use the distributive property, and when it comes to addition, you're going to have to combine those like terms. Thanks for joining me today, and watch the next video.